uh, we're going to discuss about the midpoint voltage regulation of a shunt compensation devices. Here we can observe that in the previous section we already started that the midpoint voltage regulation is very important for the long transmission lines, because of in the long transmission system the voltage sag is present at the midpoint of the line. That means in a long transmission system having length is so many kilometers, at this point, that is at the midpoint, the voltage sag or voltage dip takes place. In order to mitigate this voltage sags or voltage drop, generally you go for the midpoint voltage regulation. Here the meaning of the midpoint voltage regulation means with the help of the shunt compensation devices, we can compensate the voltage sag at the midpoint of the transmission line, while in case of the long transmission system. So we have discussed in the previous section, and also in the previous section we already derived the expression for real power. That means how much of real power is flowed while you are connecting the compensation devices like shunt compensation devices. While you are connecting the shunt compensation device, how much of real power is flowing, already observed in the previous section. So similarly, I want to derive the expression for reactive power compensation while connecting the shunt compensation devices at the midpoint of the long transmission system. While connecting the midpoint shunt compensation device in the midpoint of the transmission system, how much reactive power supported by this shunt compensation devices, which can be derived with the help of the phasor diagram, which I have already seen in the previous section. So here this is the phasor diagram of the long transmission system. The system consisting of one generation and the one load. Here this is the phasor diagram, and this is the VSM, that is sending end to midpoint voltage, and VS is the sending end voltage, ISM is the sending end to midpoint current, and X/4 is the reactance can be divided into 4 parts, because of in the long transmission system the reactance from sending end to receiving end is X, while midpoint, that is X/2. So that means the entire X can be divided into 2 parts, that is X/2 and X/2, X/2 and X/2. But here due to the sending end to midpoint, again the current is ISM, therefore the reactance becomes